ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. ನನ್ನ ಹೆಸರು ಚಂದನ್ ಎಂಜೆ, ವರ್ಕಿಂಗ್ ಎಸ್ ಎ lecturer in the Department of Electrical and Electronics Engineering, Government Polytechnic, Karwar. Now we are going to discuss about the subject electrical estimation and costing of 5th sem Electrical and Electronics Engineering. In that we are going to discuss about the unit 4 of that is power installations. So let's see the course content in this unit 4 power installation. So these are the list of course contents where we are going to discuss in this chapter. So first one, we list the code of practice for power installations, list the materials required for power circuit wiring, write their specifications. Second, solve one example and prepare the layout diagram of machines showing clearance as per IS standards. So next, solve one simple example on drawing wiring plan of the power circuit for a small workshop with one machines of 10 HP rating and decide the type of wiring system. Next we have explain the procedure for load calculations, determine the size of conductors, main switch, isolators, sub switches and protective devices for the above problem. So next we have draw the single line diagram of power distribution scheme showing grading discrimination of ratings of protective devices. So next, prepare the schedule of materials with specifications for the workshop. Here we are using only surface conduit system. And next we have prepare the estimate of cost for the above problem. And in the last we are going to discuss determine the rating of motor for IP set and explain the concept of pump house wiring. So these are the course content we are having in the unit 4, so that is power installations. So the topics which are going to cover in these sessions are code of practice for power installations, materials required for power circuit wiring and their specifications. So first we'll discuss what do you mean by power installation. So as you all know, the power installation means the installation of any motors or machines in a workshop or in any machine shop or in any large or small scale industries. So here the machines means there are maybe different size, different ratings and different kind of machines which we are going to install. So here the code of practice for power installations means while installing that machines in a factory or in a workshop, what are the standard procedures we have to follow. So that procedures are called as code of practice for power installations. So let's see the code of practice or procedures for power installation by one. First we have the main switch capable of taking the load current is to be provided, which is to be kept near the meter board. So it means for all the loads which is available in the workshop or which is installed in the workshop, so the main switch has to be installed. So that main switch has to capable of taking the full load of the workshop and that has to be placed near to the meter board. So in the main panel board, the main switch along with pilot lamp for all 3 phases and main switch of lighting circuit are to be mounted. The meter board is to be placed at the entrance as far as possible. Means the meter board must be placed entrance of the workshop so that it is easily accessible, right? And along with that meter board, in the main panel board we have to place the main switch for controlling the load and 3 pilot lamps, that is RYB for RYB indications. For 3-phase supply we have to provide 3 pilot lamps for all 3 phases indication. And if you know the workshop there will not be only machines, you have to provide sufficient lighting so that workers has to work, no? So for that we require lighting. So for that lighting circuit you have to provide one separate main switch and that also has to be placed in the nearer to the meter board. And second code of practice, the power circuit must be drawn in surface conduit system only. So here we are not going to do any concealed and conduit system or and all. So here we are going only for the surface conduit system. Suitable size of conductor according to current rating with factor of safety of 2 is to be calculated. While we have to calculate the size of the conductor depends on the rating of each machines, and while calculating the size of the conductor we have to calculate the current rating of each machines with factor of safety. Here we are considering 2 as we have calculated in the we have used in the lighting installations. Here also we are taking the factor of safety as 2. So the next code of conduct practice is flexible conduits are to be used from starter to motor, as it is to be taken over foundation bed on which motor is to be placed. Here, so from your meter board or distribution board to the switchboard of each machines we are using rigid PVC conduit, and each machine is to be provided with starter board, and from starter board to the machine terminal or machine terminals connections where the machine is placed on the bed you have seen in our laboratory and all. So the machines used to be placed on a foundation bed, right? Over the bed we are placing the machine, and from the starter board to the machine we are carrying the wires or conductors through flexible conduits, right? So next code of practice, the size of flexible conduit is calculated accordingly in view of the number of leads and size and the cable size. The length of flexible conduit shall not exceed 1.5 meter. Here means the diameter of the flexible conduits depends on the number of conductors going from your panel board or starter board to the machine bed, and the size of the each conductor, and the maximum length of the flexible conduit should not exceed 1.5 meter. Means the distance from your starter board to the machine must be maximum of 1.5 meter distance, right? Like that we have to install the starter and the machine. So next code of practice, each machine must be provided with 2 earthing, and the earth wire must be looped. 8 SWG GI or copper wire is used for earthing. Here each machine has to be earthed, right? It has to be provided with 2 earthing points, and the earth wire must not be looped. It means, so in the wiring in the lighting installation what we were doing, so we are taking the earth wire from one point to next point, and from that point to the another one point, and finally we have connected it to the earth. But here that is not the case. Each and every individual machine has to be taken separately. It has to be connected to the earth point. For that connection we are using 8 SWG GI or copper wire we are using. So that is one. Next we have individual motor is to be provided with individual TP main switch and starter in its panel board. As we know, individual motor has to be provided individual panel board. In that panel board we have to provide individual TP for 3-phase, DP for single phase, right? Individual main switch has to be provided, and individual motor has to be provided individual starter. So next we have, to improve the power factor of induction motor, each motor is provided with capacitor bank of 1 kVAr for every 2.5 HP. Means induction motor causes low power factor. So for that, to improve the power factor we have to provide the power capacitor bank for individual induction motors. So while calculating the rating of the capacitor bank, so here for every 2.5 HP we are considering 1 kVAr capacitor bank. For example, if the 5 HP induction motor is there, then we have to provide 2 kVAr capacitor bank. Like that we have to calculate the capacitor rating. For every 2.5 HP 1 kVAr capacitor bank is to be provided. So next we have panel board, meter board are to be kept at a height of 1.5 meter from floor level, and a clear space must be there to operate them without any obstacles. So any panel boards and meter boards and starter boards are to be kept 1.5 meter from the floor level, and so operator or any person who is operating it it must be easily accessible. It must be easily operatable without any obstacles. Means there should be clear space for the operation. So next we have the flexible conduit pipe should preferably drawn in a pit, and the pit is closed by wooden plank matching the level of floor. Means from the starter board to the machine foundation, we are taking the conductor through flexible conduits, and that flexible conduit preferably drawn, preferably taken through a pit. Means we create a channel from your starter board to the machine foundation, and we place the flexible conduit on that channel, and that channel or pit has to be covered with a wooden plank, and that should match the floor level, because if anybody is walking, should not get disturbed by that wooden plank. Like that we have to match the floor level. So that is one. Next we have, so above 100 kVA load, HT supply, so that is 11 kV supply is to be taken. So it means the total workshop load or total factory load exceeds 100 kVA. So then we have to take the 11 kV supply. So after that we have to install our own transformer, then it will be stepped down to 440 volt, and we will take the supply for the factory. So means if the load exceeding 100 kVA, then we have to take the HT supply, HT line, then we have to take our own transformer. So next, for induction motor up to 3 HP DOL starter is used, and 5 HP to 10 HP star delta semi-automatic starters are used, and from 12 HP to 25 HP fully automatic starters are to be used. So up to 3 HP DOL starters are used, and 5 HP to 10 HP star delta semi-automatic are used, and 10 HP onwards we are using star delta fully automatic starters, or star delta starters with timers are used. So next, MCB is used up to 5 kW of load, and above 5 kW load, along with the MCB we have to use ELCB. ELCB means earth leakage circuit breakers is to be provided. So next, all metallic parts such as bodies of equipments, covers of switch gears, etc. should be earthed, preferably with lugs fixed by means of bolt nuts. Means all the metallic parts of a motor and covers of your starter and panel boards, everything must be earthed, preferably by using the lugs which is connected to the panel board or meter board and starter board by means of bolts and nuts. So next, last code of practice we are having, to achieve a better illumination, sufficient light points are provided. It is always desirable to use industrial fluorescent fitting having reflector shades. So you know, the workshop means we have to provide sufficient lighting so that workers should not get affected by poor lighting system. So we have to provide the sufficient illumination so that workers can work without any difficulty. So for that, what we are doing normally we use twin fluorescent fittings with reflectors are used in factories. So these are the codes of codes of practice we have to follow while doing the power installations. So next we'll see the materials required for power circuit wiring and their specifications. So what are the materials, what are the main materials required for the power installations? So that we are going to discuss now. So the first material we required is main switch. As we know, we have discussed, the main switch is provided along with the meter board, and in every panel board of individual machines we are providing the main switch. So how to calculate how to find the specifications of main switch, and what are the specifications we have considered while selecting the main switch? That are the main specifications of main switches are, first one we have to take the consideration of current rating. The nominal current required for the system is found, then multiplied it by a factor of safety. So here the factor of safety we are taking 3. After finding current rating required, then the proper market availability current range is to be selected. The market availability ranges are 5 ampere, 16, 32, 63, 100, 150 ampere and higher ratings. Here, so you have to calculate the system current for where you are installing the main switch. That system current you have to calculate, and for that current calculation you have to multiply it by factor of safety. Here we are taking the factor of safety as 3, but while calculating the size of the cable we have taken the factor of safety as 2. That point you must remember here. So next, after finding out, after multiplication the current rating by a factor of safety, then you will get some value. So then you have to see the switch rating such that current rating of the switch such that what is the market availability near to that your calculated range, you have to select it. So next we have materials used. So they are such as ironclad, bakelite, porcelain based bakelite cover, etc. These are the market available, but normally we use ironclad switches. Next you have to see the number of poles. So it may be single pole or double pole for single phase supply, and triple pole for 3-phase supply. So next we have voltage grade. For single phase 250 volt grades switches are used. For 3-phase 500 volt grade switches are used. So these are the some example of switch specifications, like 500 volt 32 ampere TPIC. I mean TPIC means triple pole ironclad switch. So the rating, current rating of the switch is 32 ampere and the voltage rating is 500 volt. This is used for 3-phase supply. And next we have 200 volt 16 ampere SP switch. Here SP means single pole. So current rating of that switch is 16 ampere and voltage grade is 500. So this is used for single phase supply. Next we have 250 volt 6 ampere ICDP. ICDP means ironclad double pole switch. This is used for single phase supply but controlling the 2 wires. So the current rating of that switch is 6 ampere. The voltage grade is 250 volt. So here in this figures you can see, so this first figure represents, so this is ICDP, ironclad double pole switch. Here you can see that there are 2 fuses along with the switch 2 pole. We are provided the 2 porcelain fuse units. And the next one, this figure represents TPIC. So that is triple pole ironclad switch. Here you can see 3 poles, 1, 2, 3 poles. Along with that we have provided 3 fuse units. So these are the examples of main switches. So this figures represents the ICDP or ICTP switches. So next material we are having cable. You know the cable is required for every connection of electrical components, so to carry the current from one point to another point. So here, so what are the main specifications of cables? So first one, material. What type of material you are using? It may be aluminum or it may be copper. So next, size of the cable. The size of the cable is decided by calculating the load current to be carried after taking factor of safety. Here factor of safety we are considering 2. In case of copper, like 1 square mm, 1.5, 2.5, 4, 6, 10, 16 square mm, etc. In case of aluminum, 4, 6, 10, 25, 35, 50, 120, 195 square mm, etc. These are the size of the cable. The size of the cable is depends on the amount of current which is carrying through it, right? We have to select the proper size, depends upon our current requirement. Next, insulation. So we have different type of insulations like PVC, VIR and CTS. Normally we use PVC, that is polyvinyl chloride insulated cable. Next, number of core. So here you can use single core cable or multi-core cables. And next, voltage grade. Normally the voltage grade of the cables are 1.1 kV volt grade cables. Here in this figures you can see. So this first figure, it is showing multi-core cable. Here there are so many cores are present, right? So here in this below, there are all the cables are single core cables. These are the different sizes of the cable. So this size is depends on the current carrying capacity of the cable, right? So this is about single core cable and this is about multi-core cables. Like this, depends upon our requirement, we are selecting the suitable cable. So next we have conduits. So conduits means the pipe through which the cables are run. So that is nothing but a conduits. The main specification of conduits are, so the material. So either it may be rigid PVC or flexible PVC. The size of the conduits is 19, 20, 25, 30, 40 mm diameter. So the thickness 1 mm, 2 mm or 3 mm thickness. Example, usually 25 mm dia, 3 mm thick rigid PVC and 40 mm dia, 3 mm thick flexible PVC conduits are used for power installations, right? So here see in this diagram, this represents rigid PVC and this represents flexible PVC. As you can see, it is easily rolled and it is very flexible in nature, but it is not that flexible, it is very rigid in nature. And these are the components, like some PVC conduits components which we are using, like bends and T-joints and some saddles and all the present. These are the PVC components which we normally use in the wiring system. Next material we are having miniature circuit breaker, that is MCB. The main specification of MCBs are either number of phase, maybe single phase MCB or three phase MCB. Next specification is limiting load current, maybe 5 ampere, 10 ampere, 20, 15, 20, 30, 40, 60 ampere, etc. This is the rating of the MCB, current rating of the MCB. Next, operation after tripping, like once the MCB is tripped, how to reset it. That is the operation after tripping. It is in terms of mechanical, means manually you have to reset it. Next, voltage grade. So it may be 250 volt grade for single phase supply, 500 volt grade for three phase supply. See, this diagrams represents MCB. You see this first one, it is a single pole MCB. It is used for single phase supply to control the one wire, that is phase. See, this is double pole MCB. This is also used for single phase supply. So but to control both phase as well as neutral. See, there are two terminals for the connection. Here it was only one terminal. Next, this is three phase MCB. Here you can see there are three terminals, 1, 2, 3 terminals. This is used for three phase supply, and here this is used for three phase supply along with the neutral R, Y, B and neutral. So this is also used for three phase supply. And how to select this MCB mainly depends on the load current. The load current has to be calculated, then according to that market availability MCB rating is selected. So next component we are having earth leakage circuit breaker. The main specification of ELCBs are number of phase, whether you are using it for single phase or three phase. Next, sensitivity of tripping leakage current, like 10 milliampere or 30 milliampere. So what do you mean by sensitivity of tripping leakage current means? So all the components are earthed. So before it is connected to the earth, it is going through the MCB. So like if there is any fault in the system, then the amount of current which is going to earth is measured, right? So it senses that current, what is the amount of leakage current which is going to the earth. If it is your MCB is 10 milliampere rating, then it measures the leakage current. If it exceeds 10 milliampere, then it is automatically switched off the circuit. Means it trips the circuit when your leakage current to the earth exceeds 10 milliampere. In case of 30 milliampere, if the leakage current to the earth is exceeds 30 milliampere, then the MCB ELCB cut off the circuit. So that is the sensitivity of tripping leakage current. So next, current allowed in the main circuit, like our MCB. So how much current it has to carry through it. So that is load current it has to carry through it. So it may be 30 ampere, 40 ampere, 60 ampere, etc. Depends on the load of the system. So next, operation after tripping, like how to reset it after tripping. It is also mechanically. Manually you have to turn it on this knob, right? So that is mechanical. Next, volt grade, 250 volt grade for single phase and 500 volt grade for three phase supply. Here see this figure, first figure, it represents single phase MCB. There are two poles, single phase ELCB. There are two poles which can be used for controlling phase as well as neutral, right? And here there are four poles, R, Y, B and N. So this is used for three phase. This is the three phase ELCB. This is how to select the ELCB rating suitable for our application. So the next component we are having is energy meter. So here the main specifications of energy meter are number of phase. It may be single phase energy meter or for Three-phase application, we are going to use three-phase energy meter. And what is the next specification is current rating. So current rating of this energy meter, it may be 2.5 ampere, 5 ampere, 10 ampere, 15, 20, 25, 40, and 50 ampere. And when the total load current exceeds 50 ampere, if your factory load current is exceeding 50 ampere, then along with your energy meter, you have to use CT, that is current transformer. Suppose for example, your load current of your factory is 100 ampere, so then we have to use the current transformer. What current transformer will do? So in the primary it is having high current, and in the secondary it turns into the very small current in the respective ratio. So we are reducing the current and we are given to the we will give it to the energy meter, and the energy meter is provided with multiplication factor, depends on the CT ratio. So next specification is volt grade. It may be 250 volt grade for single phase or 440 volt grade for three phase application. Next type. So it may be induction type or electronic type. So see, this first energy meter represents induction type. You know, we are having one induction disc which is rotating it. So in the olden days we were using it. Now we are all replaced with electronic energy meter. This is the electronic digital energy meters. This can be nowadays we are using this digital energy meters for all the applications. This is how to select the energy meter. So next we have one more major component is power capacitor. You know, all the induction motor causes low power factor, right? So for that, what we have to do, we have to improve the power factor. For improvement of power factor, we are using power capacitor. How to select the perfect capacitor? This depends on the specification of the capacitors. So first specification is number of phase. It may be single phase or three phase. Next, kVr rating. So the kVr rating, it may be 1 kVr, 2 kVr, 3 kVr, and etc. So how to select it? For every 2.5 HP of induction motor, we are selecting 1 kVr capacitor, right? Next, what is voltage grade? So it is 440 volt. So next type, oil immersion insulation or insulation like mica and paper, right? So see this diagram, you can see so many capacitors of different sizes. So it depends on the type of it depends on the kVr rating. And see this diagram in the panel board we have installed, you can see this diagram. So they have installed two capacitors in the panel board of different kVr rating, right? So like this we have to install in each switchboard of the starter board of the machine, right? Each starter board of induction motor is placed this kind of capacitors, that is power capacitor. And next, last components, major materials we are having in the power installation is starter for induction motor. As you know, every induction motor is to be provided the starter, right? So and every DC motors are also provided with starter. Then how to choose the perfect starter? The choice of starter depends on the type of motor used and the BHP of the motor. Like, so for DC motor we are using 3-point starter and 4-point starter and all. For squirrel cage induction motor below 3 HP we are using D-oil starters, and up to from 5 HP to 10 HP we are using star delta semi-automatic or manual starters are used. And the squirrel cage induction motor above 12 HP fully automatic star delta starter having timers are used. Slip ring motors, rotor resistance starters along with oil immersed D-oil starters for stator are used, right? Starters are very important and to limit the starting current of the induction motors or any motors. So what are the then how to select the starter? What are the main specification of starters? So first one, number of phase, maybe single phase starter or three phase starter. Next, overload relay range of the starter. It depends on the load current of the motor. Means overload relay range current means, so suppose if your machine is taking some current like load current if of 5 ampere, so then overload relay range means it is exceeding the normal rating of the machine. Like your rating current of the machine is 5 ampere, so then if it exceeds 5 ampere, then the starter has to cut off the supply. Starter has to trip it, right? So to protect our motor from any fault or to cause the damage to the motor, we have to cut off the supply. In that case, so the relay has to operate to cut off the supply. So that is overload relay range current of the starter. So it means if it exceeds the load current or rated current of the motor, then it will cut off the supply. It depends on what? The load current of the motor. So next we have next specification, magnetic coil voltage, that is 440 volt. So next frequency, so that is 50 hertz operation. See in this diagram, in the first diagram you can see the DOL starters, so which is used for up to 3 HP induction motors, and this diagram, the second diagram, represents star delta starter. So it may be semi-automatic or fully automatic. See, so this the size, in the size of the starter itself you can identify it. It is a somewhat bigger size compared to your DOL starter. So this is used for 3-phase induction motors of above 5 HP ratings. So this is about the starter and the major materials which we are using in our power installations, right? So once we recall these materials, what are the materials we have discussed? First we have discussed main switch. So next we have discussed cables. So there are different kinds of cables, and how to select the size of the cable, it depends on our load current. And main switch also we are selecting depending upon the load current. So IC TP for 3-phase application, and ICDP or SP switches for single phase applications we are using. So next we have conduits. Conduits we are normally using flexible conduit system, as well as we are using rigid PVC conduit system. Rigid PVC from your main board to the starter board of individual machines, and flexible conduit from individual starter board to the individual machine bed, right, or to the machine terminals. So we have used. And next we have seen MCB, that is miniature circuit breaker. So this is also very important, and the rating of the MCB depends on the load current, right? So next ELCB we have seen. So ELCB, the rating of the ELCB also depends on the load current and the current sensitivity of the load current, right? So this is about ELCB. So next we have seen energy meter. So either induction type energy meter or electronic type energy meters. Now we are using electronic digital type energy meters. It may be single phase or it may be 3-phase. If the load current exceeds 50 ampere, then we have to use CT along with the energy meter. So next we have seen power capacitor. So like for example, for any induction motor, it causes the low power factor. To improve that power factor, we are using the power capacitor. The rating of the power capacitor depends on the size of the induction motor or HP rating of the induction motor. For every 2.5 HP, we are using 1 kVAr capacitor bank. So next we have seen the starter. In the starter, so up to 3 HP of your induction motor, we are using DOL starter, and 5 HP to 10 HP we are using star delta semi-automatic starter, and above 12 HP we are using star delta fully automatic starters are used. So this is about the main components or major components which we are using in the power installations, right? So next let's see some MCQs, like multiple choice questions regarding this session. So all of you try to recall the things which we have discussed till now. So then we will answer this MCQs one by one. Let me take first MCQ. While calculating current rating of cable, the factor of safety is to be taken as we have taken this, we have used this in our lighting installations and all. So what is the factor of safety? We have to take, we have to multiply the load current for selecting the cable rating. So there are 4 options like A 2, B 3, C 1.5, D 1. So as you know, what is the answer for this question? So it is A, so that is 2, right? We have to calculate the load current and it has to be multiplied by the factor of safety of 2 to calculate the cable rating, right? So next we'll see the next question. So that is the second question. The capacitor required for 5 HP induction motor is. So what is the power capacitor rating required for 5 HP induction motor? So there are 4 options provided here. So A 1 kVAr, B 3 kVAr, C 2 kVAr, D 4 kVAr, right? Here, so as we have discussed in the session, so for every 2.5 HP 1 kVAr is to be provided. Here the induction motor rating is 5 HP. So for every 2.5 HP 1 kVAr. For 5 HP induction motor, then what is the rating of the capacitor bank? Right, it is 2 kVAr, right? For every 2.5 HP 1 kVAr. For 5 HP it is 2 kVAr. The answer is C, 2 kVAr, right? So next question, we'll go to the next question. Question number 3. If the load exceeds 5 kilowatt, then if the load of your factory is exceeding 5 kilowatt, then A, MCB is used, B, ELCB is used, C, MCB or ELCB is used, D, MCB and ELCB are used. Here you can see, so if the load of the factory is exceeding 5 kilowatt, so we are using, can we use only MCB? So that is option A. Can we use only ELCB? That is option B. Or can you use either MCB or ELCB? So that is option C. Or last option, both MCB as well as ELCB. So both are to be used. What is the answer for this? The answer is D. Both MCB and ELCB are to be used. If the load exceeds 5 kilowatt, then we have to use MCB and ELCB. If the load is below 5 kilowatt, then we are using only MCB, right? So next we'll see the next question. Fourth question. For ICTP current rating calculation, the factor of safety is taken as, ICTP means ironclad triple pole switch, right? That is main switch, right? So for calculating the current rating of your ICTP, the factor of safety is to be taken as, there are 4 options. So A 3, B 1, C 2, D 4. So what is the answer? So it is A 3, right? As we have discussed, while calculating the current rating of main switch, we have to take the factor of safety as 3, right? So that is answer is option A 3. Next we'll see the next question. Fifth question. DOL starter is used in induction motor up to, means up to how many HP the DOL starters are used. Answer option is A 2 HP, B 10 HP, C 3 HP, D 15 HP. So here we have discussed up to how many HP we are using the induction motor. So that is answer is C 3 HP. Up to 3 HP we are using DOL starter, and 3 HP onwards, like 5 HP onwards, we are using star delta semi-automatic starter. For 12 HP onwards, we are using star delta fully automatic or star delta starters with timers are used, right? So here DOL starter is used for induction motor up to 3 HP. That is answer is C. Next, sixth question. CT has to be used in the energy meter if the current exceeds, like the load current exceeds. So the answer given, the options given: A 5 ampere, B 15 ampere, C 25 ampere, D 50 ampere. See here. So what is the answer for this question? If you are having the load of your factory which is exceeding how many ampere, then you have to go for CT along with the energy meter, right? What is the answer? So it is option D 50 ampere. As we have discussed, if the load current of a factory or workshop exceeds 50 ampere, then along with the energy meter you are using current transformer, right? So if then the energy meter comes with multiplication factor, that is K we are taking, right? So it means if the current rating load current of your factory exceed 50 ampere, then you have to go for CT along with the energy meter. So for this question the answer is D 50 ampere. So next we'll see the next question. So that is question number 7. Above how many kVA load HT supply is to be taken? So if you are the how many kVA load of your factory then exceeds how many kVA load, so then HT supply is to be taken. The options are A 10 kVA, B 50 kVA, C 100 kVA, D 80 kVA. Here the question is above how many kVA load. So after how many kVAs of your factory load, then HT supply, that is 11 kV supply is to be taken, right? So these are the given options. Then what is the answer? The answer is C 100 kVA. If the total load of your factory exceeding 100 kVA, then HT supply is to be taken and you have to install your own transformer, right, to step it down. Next question. How many earthing points is to be provided for each machine? Each machine has to be provided with how many earthing points? Options are A 2, B 1, C 3, D 4. So these are the options given. So then how many earthing points has to be provided for each machine? It has to be provided with 2 earthing points. The answer is A 2, right? So these are some MCQs on this chapter. So this is about these sessions. So in these sessions we have discussed what are the standard procedure or code of practice we have to follow while doing the power installation, and what are the main equipments or main materials we are using in the power installation, and how to take the specifications, what are the specifications of those main materials we have seen. So this is about this session. In the next session we are going to discuss about solving simple example on prepare the layout diagram of machine shop showing clearance as per IS standard. So this topic and we are going to discuss in the next session. I request all of you in the next session to have a pen and paper with you. These are the reference books we are referring for the subject electrical estimation and casting. Thank you.